Hello students, welcome back to our channel Diksha Karnataka. So as you all know, we have started a series where we are discussing the top 30 questions of all the chapters from chemistry. So in today's video, I'll be discussing top 30 questions from one of the organic chapters, that is Haloalkanes and Haloarenes. So this is a moderate weightage chapters. You can expect 2 to 3 questions from this chapter, but this chapter is very basic for all the other organic chapters that we have ahead, right? So I'll be discussing some important questions. This chapter is very easy and scoring topic. So let us see the first question. Okay. A pair of compounds having the same boiling point are. So you know boiling point depends on two things, that is your mass and the branching, right? So here you see this is cis and trans, that will depend because the packaging, like how ortho para happens. Similarly for cis and trans the packaging is different, so boiling point will be different because intermolecular forces are different. Now N-hexane and neohexane, these are two different compounds, so they will have different boiling points. Benzene and naphthalene will also have the same different boiling points. But here we have butane 2-ol and butane 2-ol plus and minus, right? So as you know, stereoisomers do not have different physical properties, they have different chemical properties. And boiling point is a physical property, so the correct answer for this question will be option number D. Okay, the compound is same, right? Whether it is plus or minus doesn't matter here for the boiling point. Okay, next question. In which of the following pairs of halogen compounds undergoes SN1 faster reaction? So for SN1, we have to see the carbocation formed, that should be more stable. So tertiary, secondary and primary. Okay. So now if you see here in the first option, here we have the tertiary one, okay, this one, and here we have, this is secondary one, right? So in the first combination, this one will react faster, and in the second combination, this one will react the faster. So if you check the option, this one is correct and this one is correct. So the correct answer for this question will be option number D. Next, which one of the following chlorohydrocarbon really undergoes solvolysis? So solvolysis also, it depends on the stability of carbocation. Okay, so it is an indirect question on stability of carbocation. So if the carbocation is highly stable, solvolysis will take place faster. So if you see the first one, this is a benzyl carbocation, we will get this one, right? So this benzyl carbocation is highly stabilized due to the resonance, so this will show faster reaction with solvolysis. Here it is not benzyl carbocation, here the carbocation is unstable, and here it was also unstable because it is on sp2 hybridized carbon. So the correct answer for this question will be option number A. Next, identify the products A and B in the reaction. Very simple. When we get AgCN, we get isocyanates, and we get KCN, we get cyanides. Okay, so RNC and RCN. So the correct answer for this question will be option number A. The correct IUPAC name of the following compounds. Okay, so you can see these all are nitrobenzene options. So just how we can name them to get the, so that the sum of the substituent numbers will be less. We have NO2 here, fluorine here, and ethyl group here, right? So this is, if I take 1, 2, 3 and 4, right? So 1 fluoro, or we can have 1 ethyl. Yes, so we can see 4 ethyl, 1 fluoro, based on your, this is based on the alphabetical order. 4 ethyl, 1 fluoro, 2 nitrobenzene. Okay, so the 1, 2, 3 and 4. Okay, the correct answer for this question will be option number A. You can just see this one. 4, the substituent addition 4, 5, 6, 7. Okay, for the substituent addition is 7 here. Here it is 4, 3, 7 plus 1, 8. Here we have 6 plus 3, 9. And here we have 7, right? So they have not given any position for nitrobenzene here. Okay, so the correct answer for this question will be option number A. So nomenclature, the first rule is the sum of the substituents should be less. Okay, that is why. Next question, Br2 UV light, you have been treating with so you know this one, Br2 UV light will add bromine to the hydrocarbon part, not to the benzene ring. And then here also it will add to the more stable part. So this hydrogen will be replaced with bromine. So this option is wrong, this option is correct. So the correct answer for this question will be option number B. We cannot add bromine to the ring. For bromine, addition of bromine to the ring, we use Br2 with any Lewis acid. Okay, this is the reagent. With UV light, it is free radical mechanism, it will act on the aliphatic part. Okay, next question. Order of reactivity of the following compounds. Okay, so let us see the structure. First we have PH CH2Br, first compound. Second compound we have PH CH PH Br. Third compound we have PH CH CH3Br, and fourth compound we have PH C CH3 PH and Br. Okay, so now if you see what is the order of the reaction, so the carbocation that forms should be stable, and okay, this is given for SN2 reaction, right? So SN2 reaction is more based on steric hindrance. So if the steric hindrance will be less, then the reaction will be faster. So if you can see here 2 pH group, here also 2 pH group, here it is only 1 pH group. Okay, here we have 1 pH group, but another is the methyl group. So this one will be your fastest reaction for SN2. So you can see in this first option, we have that compound, like the C6H5CH2Br. So this one will come first. Then we have this one PHCCH3Br. Okay. Then we have PHCHBr. This one is less steric hindrance. Then we have PH, 2 PH and 1 CH3 group Br. Okay. So the correct answer for this question will be option number A. So the basic thing that you should know is steric hindrance is what affects the SN2 reaction. SN1 reaction is affected by the stability of carbocation. Next, the major product in the following reaction, HBr, is taken in excess. So we have this one CH2 CH CH2OH. Okay. So when you have taken HBr in excess, so first of all what we can have is one here substitution can take place and here addition can take place. So we will get this one on addition, and here we can first get a carbocation, then excess of bromine will also add here. So we'll get bromine here. Okay, so the correct answer for this question will be option number A. Okay. So I want a answer from here. If this HBr would not have been excess, okay, it is only HBr, then please comment down and tell me whether the product would be the substitution here or addition here. Okay, so the question is, if HBr is not excess, find the product. Okay, so let us see how many of you are able to answer. Next question, which of the following halides shows the highest reaction for SN1 reaction? So SN1 we know is basically on the stability of carbocation. Here you can see one benzyl carbocation will form. Here the carbocation is stabilized by inductive effect. Here also inductive effect. Here the carbocation is unstable. But here this is benzyl carbocation stabilized by resonance. So the correct answer for this question will be option number D. Next. In the reaction, this one, how many, okay, first you have to find the product and then how many isomers are possible. So first of all, we should know if we have RMgX plus RNH2, okay, the product form is RH, okay. So what I will get, this one will be getting converted to RH, okay. Now how many isomers we can have for this compound? Another isomer that we can have is your linear chain and another is your branch chain. There is the isomers of butane, okay. So the correct answer for this question will be option number C. Okay, next. Prolonged exposure of chloroform in humans may cause damage to the liver. It is due to the formation of the following compounds. So we know this is because of the formation of a compound called as phosgene, COCl2. So correct answer for this question is option number A. Okay, next. Which of the following halides undergo hydrolysis on warming with water and aqueous NaOH? So this one is very important question. I think when we have this OH group has to be replaced with chlorine. Okay, so this compound should be highly electrophilic. Then only a nucleophile like OH minus can attack and replace the chlorine of the chlorobenzene. So when we add 3 NO2 groups, the ring becomes highly electrophilic, and then OH minus can attack and remove the chlorine. Okay, so the correct answer for this question will be option number D. This reaction is there in NCERT, important one, you can remember. Next, the compound having the largest or longest CCl bond. So we know whenever single bond is there and then we have double bond, and in between this will be partial bond which is in between single and double bond, that is if resonance is there. So here there is resonance in option A, in option B also resonance is there, in option D also resonance is there. So the correct answer here, we do not have any resonance. This is a pure single bond. It will be lengthier. So the correct answer will be option number B. Okay, next. Which of the following statements is true in case of alkyl halides? Okay, they are polar in nature. Yes, we have Rx, delta minus delta plus is formed. They are polar. They can form hydrogen bonds. Yes, they can form hydrogen bonds. Now, they have, which of the following statement is true? Okay, we have to just find true. So they cannot form hydrogen bonds, right? We have this, for hydrogen bond, hydrogen should be attached to either N, O or F. Okay, they are highly soluble in water. If they cannot form hydrogen bond, they are not soluble in water. They can undergo addition reaction. No, unsaturated compounds can undergo addition reaction. So the correct statement is they are polar nature. Correct option is option number A. Next. Tertiary alkyl halides is practically inert to substitution by SN2 mechanism because of. So this is, we know, SN2 follows steric hindrance. It is more based on hindrance of the compound or the sterically bulkiness of the compound. So the correct answer for this question is option number D. In tertiary compounds, what happens? The nucleophile feels difficult to attack and replace it because they are surrounded by all other molecules. So that is why the correct answer is steric hindrance. Easy question. Reactivity order of halides, dehydrohalogenation. So we know as the molecule becomes Ri, okay, then we have RBr. So as the size increases, the bond is poor or weak due to the poor overlapping of the orbitals. So the correct answer for this question is Ri, RBr, RCl and then Rf. Option number B. Easy question. Next. The arrangement of the following compounds in the increasing order of their boiling point. So boiling point, please remember, is directly proportional to mass, right? So first of all, you should know the formulas of this compound. Bromomethane is CH3Br, bromoform is CHBr3, chloromethane is CH3Cl, dibromomethane is CH2Br2, right? So first of all, we know chloro is a smaller compound. It will have the least boiling point. So we can have option number 3 at the least. And if you see CHBr3 will be having the highest molecular mass. So it will have the highest boiling point. Then will come CH2Br2, then will come CH3Br and the least will be CH3Cl. So the correct answer for this question will be option number C. Okay, next. The hydrolysis of the optically active 2-bromobutane with aqueous NOH results in the formation of. So we have 2-bromobutane and then treat it with NaOH, right? So now this one will be replaced with OH group, right? Since this chiral center is there, we will have another chiral center here. So we will get plus minus butane 2OL. Okay, optically active compound only will get. So the correct answer for this question will be option number B. Next question. The reaction is, this is your Grignard reagent. So very simple reaction. We have this one with MgBr, right? So when you treat it with, so this is not, this is cyclohexane. So we'll take cyclohexane here. And when you treat it with Mg ether, we will get MgBr, right? Now when you treat it with water, so what will happen? Hydrogen will be replacing it. So we will get cyclohexane. Okay, this H will come here. So the correct answer for this question will be option number D. Very simple reactions. So let us see the next question. Incorrect statement with respect to SN1 and SN2 mechanism for alkyl halide is. So first of all, some basic things that we know for SN1. For SN1, the stability of carbocation is more important, whereas in SN2, steric hindrance is more important. Okay. Next, in SN1, you need protic solvent, and in SN2, you need aprotic solvent. Okay. Now, so let us see the statement. A strong nucleophile in an aprotic solvent increases the rate or favors the SN2 reaction. Yes, that is correct. Next, competing reaction for an SN2 reaction is rearrangement. See, in SN2, there is no chance of rearrangement because there is no intermediate form. It is a transition state that is formed in the reaction. So that is why in SN2, there is no question of rearrangement at all. Okay. Next, so this can be an incorrect statement. Let us see the next question. SN reactions can be catalyzed by some Lewis acids. Yes, this can be there. So like for example, if you have one Rx okay, and you take any Lewis acid like AlCl3. So this Lewis acid can help in breaking of this RX bond. Okay, that is the that can be applied in some cases in some reactions. So that is there. A weak nucleophile and a protic solvent increases the rate or the favor SN1 reaction. Yes, protic solvent is used to stabilize the intermediate formed in the SN1 reaction. So the correct answer or the incorrect statement among the following is option number B, and that is our answer. Let us see the next question. Which of the following compounds undergo elimination reaction more easily? So in elimination also we should check the stability of carbocation and the how easily the bond can break. Okay, so here the bond is breaking between CBr, here it is CH2Cl, here it is CH2I, and here it is Ci. So obviously Ci bond breaking is very easy, right? So we can eliminate option A and option B. Now seeing option C and option D, if you see that Ci bond can break here, but after breaking we'll get a tertiary carbocation here. Here we'll get a primary carbocation. So the correct answer for this question will be option number D. Okay, next. 1-phenyl 2-chloropropane on heating with alcoholic KOH gives mainly. So first let us see the structure. 1-phenyl 2-chloropropane. Okay, so we have 1-phenyl 2-chloropropane is there. Then you are treating it with alcoholic KOH. So now here we have the elimination reaction. We have two options like this bond can eliminate here. So this HCl can be eliminated and we can get a double bond here, or this can be eliminated and we'll get a double bond here. Now if you see the double bond produced here, okay, is like and with resonance with this one, or is more stable because it is a conjugated double bond, right? So we'll get a double bond here, and if we get a double bond here, we can have conjugation or resonance is possible. That is why it is more stable. So 1-phenyl propene, that is this one. If we get this structure, here phenyl group, okay, 1-phenyl propene, that will be more stable, right? So the correct answer for this question is option number A. Okay, next. Which is most reactive for SN2 reactions? So as we know, SN2, again and again telling, it is more inclined towards steric hindrance. So here CH3I is the most simplest compound if you see out of all the options. So correct answer for this question is option number A. Next. The combination which produces tert-butyl alcohol when treated with Grignard reagent. Okay, so we can just see first option. If you see CH3COCH3, and we have reacted with CH3MgBr. Okay, so now just one trick, as I've already told you, just identify plus minus here. This is plus, this is minus because it is a metal. Oxygen is more negative, carbon is electropositive, so we'll have plus minus here. Attach the minus to plus, attach the plus to minus. So we will get CH3C to the plus. I'll attach the minus, that is CH3. Again we have CH3 and then we have O, then MgBr, right? With hydrolysis, this OMgBr will be converted to OH, right? So we will get a tertiary alcohol from here, that is tert-butyl alcohol. So the correct answer for this question is option number A. Very easy reaction based question. Next. Formation of alkane by the action of zinc on alkyl halide is called. Okay, so this is many of you may not be knowing, but by seeing the options you can easily guess the reaction. See, we have this one with RX, 2RX. If we take in presence of Na and ether, we get RR, right? And this is Wood's reaction, right? Now similarly, instead of sodium, if you take zinc, okay, the reaction is called as Franklin reaction. Okay, even if you don't know this reaction, you know it cannot be Wood's reaction, and we know Kolb's reaction is with the acid salt, that also cannot be there. Cannizzaro, there is no relation with alkyl halide. So on that basis, you can tell answer is option number D. But if you don't know, just remember this reaction name. It is with zinc. Okay. Now let us see the next question. The antiseptic character of iodoform is due to. So this is also due to the liberation of free iodine. Okay. So this is there in the importance of haloalkanes. So the correct answer for this question is option number C. Next, when CCl4 is boiled with KOH, the product formed is. So the question is CCl4 is treated with KOH. Okay. So here we get KCl and CO2 and water, right? So the correct answer for this question will be option number D, that is carbon dioxide. Next, C2H5Br can be obtained in the laboratory by the action of ethyl alcohol with. Okay. So we have to prepare ethyl alcohol is there. CH3 CH2OH, and then it is, we have to prepare with CH3 CH2Br. Okay. So whenever there is a change in functional group, what we can do is we can first eliminate this one and then add bromine, right? So if you see only KBr, it cannot replace here. NH4Br cannot do, Br2 cannot do, but if we take concentrated H2SO4, first it will do dehydration. And when you treat it with concentrated this one, H2SO4, we will get ethene molecule here, and then when you add KBr, okay, then bromine can be added. So the correct answer for this question will be option number D. Okay, next, which one is correct? Freon 14 is CF4, Freon 13 is CF3Cl, Freon 12 is CF2Cl2, and Freon 11 is CFCl3. Yes, that is correct. Freons are chlorofluorocarbons, that is your CFC, that is also correct. Freons are used as refrigerant, and this is also correct. So all the statements are correct, hence the answer is option number D. Very easy theoretical based questions. You can see from that application part also some questions can be asked. Next. Okay, identify Z in the following reaction series. So first is alcoholic KOH. We know alcoholic KOH does elimination and we get unsaturated hydrocarbons as the product. So here I will get CH2, that is your X, right? Then when you treat it with bromine, bromine is addition of bromine, we will get CH2Br, and CH2Br. Then we will have KCN. KCN will replace bromine, KCN will replace bromine with CN. So what I will get? CH2CN and CH2CN, right? So the correct answer for this question will be option number B. Okay. So any simple reaction here? Okay. So these were the top 30 questions from the Haloalkanes and Haloarenes chapter. It is a moderate weightage chapter but basic chapter for all other organic chemistry chapters. So just solve these questions, okay? Give more importance to SN1, SN2 and the reactions of Haloalkanes and Haloarenes. So if you have any doubt in any question, please comment down. I'll definitely solve them in my next video. And if you have any other requirements for your KCET exam, any other help you require, that also you please comment down. So we'll definitely take care of it. So if you have found this video useful, please like, share and subscribe our channel to get more updates on our exam preparation strategies and how to prepare and all. So thank you so much and all the very best for your exam.